Yo, it's your boy Mateo Lanchinko. Today I'm gonna talk about milk and food sanitation. So let's start with sanitation. What? 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 What is sanitation? Sanitation means measures of promoting health through prevention of human contact with the hazardous waste as well as the treatment and proper disposal waste of water. Hazards can be either physical, microbiological, biological, or chemical agents of disease. And now let me ask you a question. Why is food sanitation important? A sanitation plan is important in any food services preparation area. It ensures that all surfaces are cleaned on a regular basis and reduce the risk of transferring bacteria or other pathogens from an unclean surface to clean equipment such as cutting boards or tools.
Wow! Swagger!
And now let us talk about sanitation in food.
Do it! Just do it!
There are three main types of hazards or contaminants that can cause unsafe food: biological, chemical, and physical. Biological includes microorganisms. Chemical includes cleaning solvents and pest control. And physical means hair, dirt, or other matter. There are 5 frequently mentioned sanitation tips to prevent foodborne illnesses in food services. Let's start with number 1. Tip number 1, personal hygiene. Most foodborne illnesses are caused by bacteria or other microorganisms spread by people who handle food. According to a report called Serving It Safe from the National Food Services Management Institute and the U.S. Department of Agriculture, the report also noted that every action in food services could potentially impact food safety during purchasing, storing, preparing, holding, serving, or cleaning.
Swagger!
And now let's proceed to tip number 2, clean and contact surfaces. Proper cleaning and sanitizing of all contact surfaces and utensils is a must. According to food sanitation experts, as food can typically get trapped in places like counter cracks and in between fork tines.
Swagger!
And now let us proceed to tip number 3, sanitizing equipment. Food equipment such as slicers and fillers can be difficult to clean, especially the internal parts, where a piece of meat could get stuck and become a hotbed for bacterial growth.
Wow!
Now let's go to tip number 4, good housekeeping. It's important to apply good basic housekeeping and maintenance to food preparation areas of a store or restaurant. The Serving It Safe report notes that food services establishments use various chemicals to clean and sanitize and for pest control, but if not handled correctly, they could contaminate food and make people sick and even injure the employee. Now for the last tip. Tip number 5, safe storage. To keep bacteria and other microorganisms from growing, it is important to store food at the correct temperature for the proper amount of time. Microorganisms are most likely to grow in the danger zone where the internal food temperature is between 41 degrees Fahrenheit and 135 degrees Fahrenheit, according to the Serving It Safe report.
Swagger! Wow!
And now let's talk about pasteurization. But first, let me ask you a question. What is pasteurization? It is the heating of every particle of milk or milk product to a specific temperature for a specific period of time without allowing recontamination of milk or milk product during the heat treatment process. Have you ever wondered why is it called pasteurization? If you think pasteurization is an odd name to give to heating food, you're right. The process is named for its discoverer, French biologist Louis Pasteur, who stumbled on the idea in the mid-19th century while trying to discover exactly what made food go bad. Pasteur had trained in science and was working at the University of Lille, France. When some winemakers invited him to solve a problem they were having, they couldn't figure out why certain of their wines were turning bad more quickly than others. With the help of microscope, Pasteur discovered that the yeast used in making wine and beer contains different bacteria. Some of the bacteria helps to produce the alcohol in the drink from sugar by a process called fermentation, while other bacteria turns the drink bad after it's made. Pasteur's simple solution was to heat the wine briefly to kill off the harmful bacteria so the drink wouldn't go bad so quickly. This idea, which became known as pasteurization, proved hugely successful and was later adapted to help preserve a wide range of other food and drinks.
Wow! Swagger!
The process of pasteurization consists of ultra-pasteurization, high-temperature pasteurization, low-temperature pasteurization, and raw products. There are 8 steps of pasteurization. Step number 1 is milk chilling. Chilling is not a pasteurization process, but it is a necessary step when dealing with large volumes of milk. Milk leaves the cow's udder at temperatures above the ambient, which encourages rapid bacterial multiplication that speeds up spoilage. However, reducing the temperature to between 2 to 5 degrees Celsius arrests bacterial growth and metabolism. This provides a head start at keeping the quality before proper pasteurization commences. Step number 2. Preheating, regeneration, and standardization stage. After bulking, the chilled milk is heated to about 40 degrees Celsius to facilitate easy separation of butterfat during standardization. The system uses regenerative heating. It uses the heat of the already pasteurized milk to heat up the incoming chilled milk. The chilled milk in the counter current flow cools down the pasteurized milk. The purpose of standardization is to obtain product with uniform content of butterfat. Step number 3. Clarification. Clarification is essential for removing all foreign matter from the product. Large solid particles are removed by straining the milk through tubular metallic filters. A centrifugal clarifier is used to remove all soil and sediment from milk. The filters, usually fitted in parallel twins, permit continuous processing as one can be cleaned while the other is running. Clean the filter regularly between 2 to 10 operational hours depending on the level to avoid growth of bacteria. Step number 4. Standardization stage. It is important to standardize milk fat to ensure that you end up with a product of consistent quality in the market. Different consumers prefer different products. There are customers who will consume skim milk only, while there are those who will take low-fat milk. There are those who will take standardized milk, while there are those who prefer high-fat milk. Standardization is necessary to ensure that all the customers are catered for. Again, it is during the process of standardization that you get to separate the butter fat that is used for making cream and other fat-based products such as butter and ghee. Step number 5. Homogenization stage. Homogenization is a physical process of breaking down the milk fat globules into tiny droplets to discourage cream separation. Tiny droplets of fat do not rise in milk columns, since reducing their sizes also increases their density in the milk. A milk homogenizer working at between 100 to 170 bars split all the fat globules into very tiny droplets that increases the level of integration of the milk fat. As a result, the milk fat remains uniformly distributed in the milk. Step number 6. Heating section. Utilizes heat from steam to raise the temperature of the milk from about 60 degrees Celsius to the required 72 degrees Celsius that is effective to kill Clostridium botulinum spores. The stream exchanges heat from the milk across the PHE plates in the counter current motion. At the end of this section, there is a temperature sensor which controls the flow diversion valve. Any milk that does not attain the required temperature is diverted back to the heating section until it attains the required temperature. Step number 7. Holding section. After heating, milk flows in the holding tubes whose length have been calibrated with milk flow rate to ensure that milk takes at least 16 seconds in the tubes. All the milk must maintain the required pasteurization temperature at the end of tubes. In case of a breach, a sensor will trigger the flow diversion valve to take the milk back to the heating section to bring the milk to the required temperature. Once the milk was attained the required temperature at the end of the holding tubes, milk flows back to the regeneration section to heat the incoming chilled milk while in itself being cooled down to about 30 degrees Celsius. Step number 8. cooling or chilling section. After regenerative cooling of pasteurized milk, it moves to the cooling section of the PHE, where chilled water PHE coolant lowers the temperature of pasteurized milk to 4 degrees Celsius. The chilled milk is then pumped to the packaging machine for aseptic packaging and subsequent storage in the cold room. Thank you for watching. Please stay safe. That's all. Me out.